I am Dr. Aristotle Ganeshan. Would like to share with you the hydrogen energy related concepts because hydrogen energy is booming now. Today the hydrogen status is the global demand of hydrogen is 100 million metric ton, 100 MMT in 2030. US production as of now is 10 MMT, million metric ton. India demand or targets 5 million metric ton in the year 2030. China consumes 24 million tons per year. China is the largest consumer in the world. The specific energy of hydrogen compared to the other fuels, say diesel, gasoline, petrol, ethanol and all. So the hydrogen specific energy is around 140 kilojoules per gram. 1 kg of hydrogen contains 33.33 kilowatt hour. This is an energy density of hydrogen. Because of this reason, the hydrogen is most concentrated in the business. There are three types of hydrogen: grey hydrogen, blue hydrogen and green hydrogen. There are three categories based on its production method and based on its byproduct. The main process of the grey and blue hydrogen is reforming or gasification methods. In blue hydrogen, it is reforming or gasification with the carbon capture. In both cases, grey and blue, the energy source is fossil fuels, right? But CO2 emission in both cases varies. Grey hydrogen is higher, blue hydrogen is less compared to grey. In green hydrogen energy, the process is electrolysis. There are various types of electrolysis are there. We can discuss those things later. Here the energy source is renewable electricity, say wind or the solar energy. The estimated CO2 emission is zero here. That is the reason why we are concentrating much on green hydrogen. The global hydrogen consumption by industry wise. Say petroleum refining industries occupies 25%, ammonia production 55%, ammonia for fertilizer and other use, and 10% is a methanol production, the application of methanol everywhere including shipping industry and all. 10% is through automobile running through fuel cell vehicles. So these are the global hydrogen consumption by industries. Uses of hydrogen in specific to the petroleum refinery industries, and hydrogen is used as an electricity power source, and it can be used as the synthesis for the ammonia for the use as a fertilizer and food industries, and the hydrogen binds a molecule together in the chemicals, the pharmaceutical industries, and the hydrogen extreme heat and cold help the manufacture of electronics, metals and glass. This chart refers the blue hydrogen and its the process and application compared with the green hydrogen. You can see here the production of blue hydrogen and its the chain management, transportation and to the various application. Here the green hydrogen is synthesized through renewable electricity and electrolysis, and it is supplied through the transport to the various industries and its application industries. When you compare the cost of hydrogen per kg of hydrogen, the green shade refers around $1.45 per kg of hydrogen, and in different regions of the world, South America, North America, India, some parts of Asia and Australia. Blue color refers the little higher cost, say up to $1.77 per kg of hydrogen, and the other shade is 2.08, 2.4, etc. So it shows the hydrogen cost per kg $1 to $2. Normally when you talk about the hydrogen, you may worry about the safety. It is highly inflammable. A proper safety norms has been derived for this successfully. Hydrogen is non-toxic, so it is safe. It's much lighter than air, so it easily dissipates. And we need additional engineering controls to enable its safe use rapidly when it is released. So hydrogen is widespread in the atmosphere and lower ignition energy than the gasoline or natural gas, which means it can ignite more easily. So like other CNG gases, it also needs the adequate ventilation, leak detection are the important elements in the design of safe hydrogen systems. Hydrogen burns with nearly an invisible flame, so special flame detectors are required for this. Some metals can become brittle when exposed to hydrogen, so it is called a hydrogen embrittlement. And the last one is 4 volume percent of hydrogen in oxygen is needed for blast. It's a condition. In India, there are various companies are playing a major role in the production of green hydrogen, and they are involved in the hydrogen production, especially green hydrogen. Let me start with the Indian Oil. It's a 5% of the hydrogen production should be the green hydrogen in the year 2027 to 28 and 10% to 2029 to 30. The second one, HP Petroleum. It aims to have a green hydrogen capacity of 24,000 tons a year. And Bharat Petroleum, it is going to install 5 megawatt electrolyzer system to set up a green hydrogen production. And Greenco is another MNC corporation. It plans for 5 billion in the storage of carbon-free green hydrogen. Next, Adani Renewables, they invested $50 billion in the green hydrogen production. Initially, they started 3 million metric ton of green hydrogen in India. The last one, next one is the Larsen and Toubro. They commissioned a green hydrogen plant in Gujarat. It is already commissioned in August 2022. The plant produces 45 kg of green hydrogen on daily basis. Then next is a GAIL. It plans for 4.3 million tons of green hydrogen per day. That is a 10 megawatt capacity of the system. It is scheduled to be commissioned in November 2023. Reliance Industries is also planning for 75 billion on clean energy projects over the next 15 years. NTPC is also planning for 5 gigawatt capacity in green hydrogen and ammonia business out of its 60 gigawatt green portfolio target in the year 2032. And ONGC is also planning for 6.2 billion on renewable energy and green hydrogen energy projects. These are the status of the companies involved in the hydrogen production or hydrogen generation in India. There are so many companies are acting as a global players. Only few are I listed. McPhy, Air Liquide, Siemens Energy, Cummins, ITM, Nel, Sunfire, and Teleon Technologies, Plug Power, Elogan, Ashakishe. There are so many companies are the global players in the green hydrogen energy production. In India, it initiated the green hydrogen energy mission under Ministry of New and Renewable Energy, MNRE. They started National Green Hydrogen Mission. And according to this report, they are planning for 5 MMT of green hydrogen by 2030. 6 lakh new green jobs will be generated. 50 million metric ton of carbon abatement in CO2 reduction will be there. 60 to 100 gigawatt electrolyzer installations. 125 gigawatt renewable energy for green hydrogen production. Over 8 lakh crore investment will be there, according to the report. So, here the employment opportunity is concerned, 6 lakh new green jobs will be generated in future. The global benefits of hydrogen economy in the year 2050, it will be around 30 million jobs accumulated across the world. It will be generated. We provide training and certification on hydrogen energy and fuel cell technology for the students, school students, college students, research scholars and teachers. And we provide industrial training and on-site training. On-site means at your doorstep. So, we provide a proper certification also. If you need any requirement on training, you can contact me. I am Dr. Aristotle Ganesan. My email is also listed, arisamudha@gmail.com. Thank you very much.